So yesterday we looked at the two methods for digital, analog, or Benon, and where you were not, we tried to say that whatever, whether it is music or whether it is a ringtone, it came to that phone, whatever it is, was digital. If it was a phone call, it came as a digital signal when it was a phone, but we have been able to hear the sound as far away as we were because of the vibrations of the air. And then when the air vibrated, we were able to hear the sound. Meaning, we are trying to explain to you what we did not hear yesterday. So that is, we are able to change a digital signal into an analog signal. And we were able to hear that sound because of the speaker, which is an analog device. It changed whatever was digital within the circuits of within the inside of the phone. So if you are on YouTube, or if somebody sent you a voice note, they use the microphone of the phone, which is analog. It goes into the phone, it is turned into beats. 101010, and then gets transmitted over the internet, over Wi-Fi, or whichever other method you are using, 4G, ADC, and then it comes to you. And then when you press play, it started being audio by compressing the air into the microphone. It was analog. It was the pressure of the air as I talk, the pressure. But if there is a music concert or a disco somewhere, if you have very weak windows, you hear them banging themselves because of the air, and it is instant. It comes instantly because there is air everywhere. If you are teaching high school kids and you want to explain how air occupies space, then you just get a glass. You get a glass, and then you put in a piece of paper up to the brim. And then you dip it into a jar or a container of water. If you make it touch, if they make the brim, the top here, touch water at the same time and you push in, if the water is too much, you can even make the whole glass deep inside and be there for some time. If you release nicely without any bubbles and remove, when you get the paper out, you find that the paper is damp dry. That's the easiest way to show that air occupies. So much as we don't see any air, but there is air everywhere. So when I talk, I compress it. And because of the compressions and rarefactions, then you transmit the sound. At a pulty, slow pace, 330 meters per second, about 3 pitches per second. Before you breathe in, out, this sound covers a football pitch. Comparatively, when you hear a bullet, don't worry, you are okay. If there was chaos and here, don't worry, just continue saying where, because you are not dead. A bullet travels 7 pitches per second. Travels at 700 meters per second. Before you breathe in, it has moved 7 pitches in a second. So if it was pointing at your heart to kill you, you won't hear it, because the sound of the gunshot would be moving at almost half the speed. So when you hear a blip sound, just rejoice. Say, yeah, I'm leaving for another few seconds. If the guy was only shooting one bullet, but if he has many, the next one you won't say nothing because you'll be dead, because you can't hear. That's why you have to have a cannon at one place, and then make sure that that cannon, you are able to see the light. So you start the stop clock when you see the flashlight, and then you stop the clock when you hear the sound. And then because you are stationed at a point where you know the distance between, then you can actually practically measure the speed of. So back to the beat, just to show you that the pressure that is causing these compressions and rarefactions, pressure is analog. Pressure is one of the analog variables. Temperature is one of the variables. Continuous. All these, then you have volume. You can keep pouring and pouring, and which other one would be? And all these ones can take on continuous values, and this is the precursor for analog. And then if we have this continuous variation of these pressure and volume, voltage, current, ADC, then we can chop them into pieces. We can chop them in two pieces, and this process is what we call polarization. You have these keywords. You need polarization, sampling, so that you can now be able to chop them into when they are high and low, high and low, high and low, and be able to get sense out of it. And so we got methods of doing this, and for the benefit of making sure that we improve accuracy, we can benefit from repeatability, we can benefit from the advantages of digital. What did we say? Accuracy, repeatability, flexibility. It is flexible. The other one, you got them in your notes.
Regeneration.
Generation. Let's do what we had yesterday. I'm trying to revise for yesterday for the benefit of those who were not there. Mugabe. The other one is complex tasks. And then lastly, the other one is four. I got them here, so I don't trust you. So we do this, and to change, eventually to change from digital to analog, like if you had a keyboard, you move keyboard is analog, then you see on the monitor within the computer. Of course, the monitor is just an evidence of what is going on in the CPU, central processing unit. And then you have the monitor now is the analog part of showing you. Now if you had some music on the computer, you would play it through a speaker. The speaker is now analog. You are now expressing what was digital this way into the speaker. Taka and joy. What do you want to make in the last days? Very hard days. Very rigid man, eh? Very rigid. So, Ajahn, how far we have gone. And once we know all these things about the conversion, the reason why we convert, then we did the conversion using the weighted meaning that we had a bunch of resistances in the form of R, then 2R, then 4R, then 8R, for if we are just looking at this being a 4-bit. Then we graduated from a weighted to a ladder method, and we ended at a ladder method where we had the diagram with the VREF, and then we had the RRs here. And then this is equivalent to simply having the VREF here. And what is the effective resistance of this whole thing? Napopoli. What is the effective? We start from here. This is 4R squared, product over sum, yes, 4R squared over 2R. 4R. Yeah? Then we add it here. But isn't that? This is 4R squared over 2 over 4R. Over 4R. Which ends up being R. Then we add here, it becomes 2R. Then it becomes R. 2R. Then it becomes R. 2R. Then it becomes R. Then we have 2R. I don't know what I'm saying. Anyhow, this is, it ends up being the R. The effective resistance will be R. This is I ref. This is R. But let's do it. Let's do it so that we don't cram stuff here. I told you we start from the foot soldiers. When we are looking for effective resistance, we start from far away from the power source. So this is the 4R squared over 4R, and this is now R. So I will rub off this. And then this one is R, and then it becomes 2R, and then this one gives us R, is that okay? Yes. Which now makes it 2R, and then it becomes R, which makes it 2R. This was supposed to be complete, so let's try to complete it. And then this one becomes R. So this is how I'm ending up with this one. So you can see the ladder makes life a little bit easier. And then of course here we have the grounding. And hence this I reference is the same as the voltage, which is V reference over the effective resistance we have, which is R. And then we have for the IK. So for IK would be the same as the IREF over the 2 to the power. This is the this is 2 to the power. We are having a 4-bit, so it will be 4 minus K for any case current, and K is the 0 in steps of 1 up to 3, since we are having a 4-bit. And then the IF, this whole thing was fed into the operation amplifier, remember? And we had an RF with the IF. So the IF feedback current is the same as the V out, output of the operation amplifier, divided by the RF. Just summarizing a few things about these methods. For an ideal operation amplifier, then we have the sum of the currents from K equal to 0 up to 3 of them, since we have 4-bit. Then we will be able to have summation, summing all of them, I1, I0, I1, I2, up to I3, and then this is IK, will be equal to 0, because there is no current that is entering all this ended up going to the op-amp. The ladder method, we had the switches. When it is on the ground part, it was 0, and when so each of these had a switch and going to so one was either going to this other part here. This one was either up here for 1 or here for the ground. And here we had the ground. Then we had our operational amplifier with the RF for IF. It's now just drawn one of them. This is for 2R, for the first one. So this is for IF, for example. You have the data. Hence, V out is equal to the minus RF over R, V ref, into a half plus a quarter plus an eighth plus a 16th, and then in general, if we had a bunch of many other, then we would have the V out This is for n bits. This is for up to 3 bits. For n bits, sorry, small n. Then we will have V out being the same as the full scale range over the 2 to the power n. That will be our V ref in the summation from I equal to 0 up to n minus 1, then 2 to the power I, then b, the bits, b out. And this is the full scale range here. Is the same as minus f over r times b reference, where FSR is the full scale range. Now for we are seeing stars because you were not there yesterday. Don't get worried. These are formulas which are used, but if you take electronics and instrumentation, we shall dive deeper in this part of the digital and analog conversion by considering the transducers. Note, for any time we want to look at the signal transforming from analog to digital, digital to analog, it is of paramount to know the resolution. How nice is it getting? And the resolution, delta V will be the same as the full scale range over the 2 to the power n. And the summation I equal to 0 to n minus 1 would be I, the 2 to the power I bi would be the same as the eventual decimal number that we will get. Remember when we had 0, 0, 0, 0, 0, 0, 1, 0, 0, I mean 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1. But then when we went on the left, all those were now being described as 0, 1, 2, up to 9 in decimal, in base 10. The switches which when you switch on S3, that means you are the third bit is the one now which is considered. If all of them are on, we have up to the 3 bits. So the switches usually, which are usually field effect transistors, field effect transistor switches. This is somebody who made a statement that FETs can be switches and BJTs cannot be switches, something like that. I don't remember. Some of you really get answers which are from heaven. So these FET switches in form of chips. In form of chips. So these chips may be confused with French fries. I need to say in form of integrated circuit chips. Those chips which you have been using for D1 and D2. The resistors, so the switches you saw are not that you are having a switch that will be switched on and switched off. It is you use this. So if you have this R here, these two are, then you have a switch switching to switching here can be made of FETs, which will keep alternating. You have the current flowing, it goes there. Once it goes there, then you get the beat. The beat shows up. Then when the other state, it is on the off, on the ground. So you keep having things just working. So they work on their own. They are automated. And that's how a circuit board of a computer works. It's a bunch of D latches and flip-flops, which are automated. They keep doing it. So when you switch on your PC, the thing starts. Then now you know it is bringing the screen, welcome to Windows 11. After Windows 11, then it now brings the, if there is something which was saved in a D latch, in a data latch, then you were working on a Word document, then it brings. You were working on them, which recover the previous document, yes or no, like that. And you know when you are dealing with computer, those of you who did some introduction to computer, opening a computer is like, if I am dressed, if I'm getting dressed, I put underwear, put my trouser, or I put a vest, put a shirt, put a coat. Now if I'm undressing, I cannot undress from the vest first. I have to remove the coat, remove the shirt, remove the vest. You get the point? So it is, you have to follow the same step. So the switches, these switches are made of FETs, and these are in form of chips. That's why when you open a PC, you just see a bunch of chips and small lines going everywhere. And so the resistors, these resistors in the ladder, which are ending up being just one resistor, the ladder made in thin film, ladder made in thin film form. Chip. So it's also a chip. So you've seen like some sheath, like not sheath, like some film. You open a laptop and all you are seeing is some brownish thing with some lines there, and then where it terminates, you find that there are some, and then you plug it in somewhere. So those are what we are talking over as a thin film, which is having these resistances, HT. So it's not like you are going to find resistors. Now, if you open the laptop and there is no resistor anywhere, don't feel bad that this man told us of a ladder method. Now we are seeing a digital gadget like a laptop, but there isn't any resistance in a ladder form. They are made in a thin film and in the form of a chip, an integrated circuit. Most practical digital to analog converters circuits are based on this R to R ladder method. So you will find most DACs using this method because of its simplicity. You just need one resistor duplicated in a ladder and can also be made easily in the form of a thin film. And then the other ones, the switches, are made into FETs, which are just a bunch of chips. And then everything is automated. Like I told you, I cannot undress from inside. I have to follow the procedure. And those are a few things that made me learn computer and feel comfortable with playing around with the PC. For me, when my PCs are not working, I don't hustle. I just do something else. So I read the book as I was waiting for a PC. These things of being frustrated, don't be frustrated by your phone or your PC. When it is loading, just do something else before you know. And if it sees you not caring, it hurries. It hurries. You see it now opening very fast. But when you start putting the cursor, you are like this. My assignment. Then you get issues. Now, it seems to be very easy to change from digital stuff to analog. It's easy to plug in a microphone, to plug in a speaker and you start enjoying the music. You just get your subwoofer, plug in the SD card, get the speakers and plug in the parts of there where you put like wires like this and put, if it is like in my vehicle, you just get a subwoofer, plug in banana cable and immediately music is booming. Now, it's easy as that. Because you have just changed your digital signal on the radio, on the digital radio, in the vehicle, on the phone. Or you just plug in the earphones and you start shaking your head. It's as easy as that. But how about if you have a radio cassette tape and you now want to make it a DVD? Do DVDs still exist? My DVD player died, but it used to show nice movies. Nowadays, I don't need to see anything in a DVD player because I can put a whole external drive on my TV and I start watching nice movies. Although I have some old ones, I can't. So there is no need for another paper. I put them together today. So I don't know whether I told you, if you have your parents' old cassettes, even if they are audio cassettes, don't feel disappointed. Just get a two 40 jack cable, which has, is it 40 jack? I don't know how they call it, but the one which has two pins on the left, both ends. They are used mostly on Bluetooth speakers. Now plug one side in the mic of your computer where you want to record your stuff. Plug the other one in the audio out of your cassette, the old cassette, if you have an old cassette. First make sure that you use feedback tricks and see whether you are producing. I still use my laptop, which is XP. Nowadays it has lost a screen, so I may not use it anymore. But when it was still working, that's the one I used to use because it had a recording part, which would show me a scale. Like you would see beeping LEDs. Okay, they are not LEDs, but the lights will beep. Then if I increase, I see if it is now red, it goes in green. And then I let it now play. Then you can, this one you are playing on a radio cassette, you can now transform it on a laptop into a digital music. So that South African music, that Lingala, whatever, or Mana Umzum by Kafero, all those, you can put it in this format, and then after you have put it in this format, now you can chop it. You can use an editor, an audio editor, whether you call it a movie editor or an audio editor, then you start editing off the stuff. If there are vulgar words, Kafero said, and you don't want to listen to them, you chop them out and leave the only thing you want. And you can have your music now, all these boxes of audio tapes, you now can transfer them into. And on Christmas, you can go to the village and play for people music of those days. And they are like, our son, thank you for having gone to the university. Instead of having to lose your stuff. So I did that. I transferred one audio cassette, one audio cassette for is a Pan-Africanist. It's called Roy, and when I put it on YouTube, it's now about 80K plus people who have listened to it. But it was a cassette which I changed into a video kind of. Of course, it's still audio only, but at least it can be viewed or watched on, not watched, but listened to on YouTube. People loved it, and there are a lot of stuff which people have recorded before, and they are somewhere kept without being used. You can work using electronics. I hope you have understood this. So let's now go to analog to digital conversion. You see the hassle you plug in, you have to adjust. So then how is my audio being turned into? So common methods used in order of their decreasing speed, in order of decreasing speed. So that, what does that mean? The first one will be more speedy or less? More. So one is a flash of parallel converters. So this you are saying is what? Is speedier according to the statement. But engineer. You had two. Both. That is not yours, eh? Hey, you're about to... The results are good. The results are good. Two, the second one is successive approximation. Successive approximation method. And then three is the dual slope. The dual slope method. Now you have, or you will experience this idea that you got the phone, but because you don't have the app, then you can't actually play the music, for example. You have the, if you don't have an app, for example, it's called ADC or VCL. VCL. If you don't have this app, I think it looks like this. Something like this with some characters. If you don't have it, you may not play some music, you may not play some videos, because the converter, that converter is not there. It's not that it's supposed to be an electronic circuit. Apps now replaced the physical bit that we see in electronic circuits. So and that's why now for me, when they say AI is going to take jobs, robotics are going to take jobs, I laugh. Robotics do not build themselves. They are designed by people. The only thing you have to know is that you have to grow. You have to traverse from lousy nature of understanding things to now smart stuff. When AI comes, don't listen. Now start understanding what AI is. So if robotics, if they are saying now we are going to rely on robots, now understand how robots work. They will look for you. At that moment they want to design a robot. and now you'll be the guy who designs robots. You say, if you want an industry with robots doing the packaging, then now you are the one who plans. And then you can go ahead and actually make sure that you are an expert on how these robots should be arranged in the industry for efficient production. But some people just give up and they're like, oh, now robots are going to take our jobs. Technology is taking away things. Which technology? Technology is not standalone. It still is driven by human beings. Even AI is trained by human beings. You are the one to train it and say, I want it to do this and that. So let's start with this flash. Just like a flash is that fast. So flash and others. And these are the fastest. These are the fastest others. Why? Input signal. Input signal is compared at the same time with several the input signal is compared at the same time with several subdivisions. Subdivisions of the reference voltage. E.g., we're going to look at a 3-bit flash converter and see how it looks like. And then 3-bit, we use comparators. Comparators are the op-amps. So we use comparators, and if it is a 3-bit, then we need about 2 to the power 3, which is equal to 8 comparators. That's one thing. So if we have 8 comparators, then we gotta subdivide the reference voltage. So that means we would have about 8 sub-reference voltage or voltages. And how many resistances? If we have 8 subdivisions of the input, of the reference voltage, how many resistances do we need? We shall need 9 resistors. And this is how we shall arrange the flash converter. I need enough space. So I will have the input, and then I will have so under this, on this input, I will now pick out to the comparators. So I will start with the first comparator. Comparators are op-amps. And then the other one goes to, I don't know whether, I want to be sure that I'll be able to have drawn it. 8 these are the operators. Okay, let's see. I did finalize. So I will see whether I can. So I got another one here. I got, it's you who will suffer. Yeah, I will go. I will be busy. It's you who will hustle now with, how many are these now? 5. I need 3. They feed. Then 3. Haven't they feed? Then this other one. So I will have this last one terminating here. And then this one goes to the set of resistances. So resistances are the ones which are going to give me trouble because they are supposed. So I will have a resistor here. And then I will have the VREF. And then I'll have a resistor embedded in the middle of each of these. And then here, and then here, and here, here, and the resistor here. I'm sorry, the resistor may look fake now, but it is your, it's up to you, you hustle. How many are these? 1, 2, 3, 4, 5, 6. They are supposed to be, there is 1, 2, 3, they are supposed to be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Have I jumped any? Yeah, so 1, 2, 3, 4, 5, 6. This is 7. But these are 8. 1, 2, 3, 4, 5, 6, 7, 8. Where am I losing? I need more 3. Have they reached?
Yes.
9. So this one now, the subdivisions. The subdivisions are, so we have 8 of them, and this will be here. The one which will be going here will be V8, V7, V6, V5, V4, V3, V2, and then finally V1. And these are, we have R over 2, this one, and this is R over 2, and all these other ones are R. And then this one is comparator 7, comparator 6, comparator 5, comparator 4, comparator 3, comparator 2, comparator 1, and then comparator knee. This is plus, this is non-inverting, inverting, non-inverting, inverting, non-inverting, inverting, because these are ending rapidly ground. Non-inverting, inverting, non-inverting, inverting, non-inverting, inverting, non-inverting, inverting, non-inverting, inverting. And this is the priority. This is the priority and order. When we are moving from analog to digital, we encode. When we are moving from digital to analog, we decode. That's why when we are having satellite signal, which is digital, and we want to use a Nyash TV, we decode it to make sure that we decoding is from digital to analog. And then encoding is when we are moving from analog to okay, so we shall be able to look at this further tomorrow, and then we look at the dual slope very fast, and then look at the transfer function, and then I just summarize the course. I don't want to hustle you up. For those who are doing education, I just want to make sure that you learn how to plan your time and cover what you are supposed to cover with no stress. And so the Wednesday group, we meet in the afternoon for our last practical. We have one which we haven't been able to do, but you can just pass through the lab and look at the other experiment, which these are they 2 or 1? For Wednesday group, I think it is only 1, which you are going to miss, the one which would have been on Saturday. The Friday group, you are unfortunate. Jesus died on the day of betrayal. We missed, and then also when people were still crying on Easter Monday, we also lost another chance. So I'm sorry that I don't finish early and give you a week of revision like children of primary 6. I don't have that time. You are mature. We should even finish today and tomorrow you do an exam and pass. That's how a semester system, I explained the semester system at the beginning, and the governor was my witness. Those days it was term system. They teach you things on January and they can bring them in December. For this time we teach you things in January, and in May you do them and you have the right to forget them. Freedom. So that means that you have to make sure that each lecture counts. For the 3rd year, in your 3rd year, since now you are going to 3rd year, make sure that each lecture counts. Whatever the lecturer says goes into your head. At the end of the semester, you get your A's. Being lousy during lectures, semester reaches and you don't remember, and things are many, and you don't know where to begin from. But take each time, make it a process. Attend all lectures, take notes. When others are watching, revise those small notes you took in class. Do some research. This is called research. Do some research and get more information about it. So when I teach about this stuff, go see how it is grown exactly from internet. And listen to some videos online by experts. I'm not an expert. I'm just a survivor. I will teach you about, I've not seen I've not seen, well, I've seen circuits in a computer, but I've not seen exactly that this is the one which is a flash converter. But there are those who design them, those who build them, and they are online explaining them. So when you listen to them, you're better off than me. You just make sure that I know how they work for purposes of earning a living, and teaching you how they do. I don't know how to show off, I tell you the truth. So, but my dream is to make an electronics workshop which works. That's my dream. I used to have one when I was young, but I went back to check, I couldn't find my toolbox. But now I want to do something. Since I'm a mature person, I can buy stuff. And maybe since the craze now is on skilling, I can tap some money from State House for skilling Ugandans in electronics. Because electronics guys are here, they are not many. You are still struggling? Yes. Okay. But I gotta go. But it will be on the way in a few minutes. It will be on the way in a few minutes. And, so allow me to chop it off. Because I can't trust anyone of you to clean my board. When they were training me, they said, leave the board the way you found it. Although sometimes I find it dirty. What do you have now? Do you have a lecture now?
No, next test afternoon.
Is a test afternoon?
For the electronics.
For the lab? Okay, so you will finish this diagram from where I'm going to post this video and zoom in, but I can also screenshot it and make it a big one on the page so that it is visible. So don't feel bad that I have to work with that. I make life easier. You see me, you can be taught by me when even you are sleeping.